this is going to be strange. It's better. It's a little better. Everybody see that all right? Should I turn the other one on? You guys good? So y of 0 is 0. So I've got to go through this point here. And then as I look this way, I just follow what this kind of tells me to do. And it looks like it's telling me to do something like that. Now this is by hand, so it doesn't have to be absolutely perfect. So maybe you guys have a little bit of wobble to it. You average all of ours out, and you might get something close to the reality. And this way, it looks like it's kind of going the other way. So that's the solution curve. I don't even know what the hell the function is, but that's what it looks like, the answer, which is really weird. We normally don't do that. Let's get what the answer looks like first before we get the answer. We just did. What if y0 is 2? So that's going to be right here. So going back this way, it looks like it goes up. And if I go this way, it looks like it takes a real quick turn up. It looks like a very tight little parabola thing. Is that cool? Is that what you guys got, roughly? Again, it doesn't have to be absolutely perfect. You have to show me the idea of you're just following where the things are telling you to go. I like it. Okay, so that's not evil. Making those could be evil, of course. That's why I don't normally have you do that. There is one problem. It talks about some interesting idea called isoclines. Has anybody tried that homework problem out yet? I like your honesty. So I'll let you tackle that one. It's a way that was done by hand before we had computers do it for us. So that is the one problem I think I signed that for you to do this by hand. Because there's a shortcut to it to make it easier. So we'll see if you understand it. So number 2, of course, the first thing I do is just...
Because I know this one.
Is what?
Factor of y squared.
So you get y squared times 9 minus y squared, so you get y squared 3 minus y, 3 plus y. And again, like my algebra students wouldn't understand that how is that different from y minus 3, y plus 3. We know all too well it's going to change the signs on the directions of my arrows, right? If you don't get those the right way around. And then you just need a single line. My pivotal points, of course, are 0, 3, negative 3. 0 is multiplicity 2, so I know that the direction of the arrow is not going to change around 0. That's how multiplicity helps. It's also a really cool movie by Michael Keaton, but it has nothing to do with this.
Can you spell out the word?
Multiplicity?
Yeah. Oh, is that simple?
I live in multiplicity. So even multiplicity, it's going to stay the same sign, just like a parabola would. It turns, right? And this should sound very familiar. This is how we did this kind of thing back in pre-calc, maybe. So I got 0, I got 3, I got negative 3. So if I put 18 billion in there, I get positive, negative, positive. So up here it's... Multiplicity at 3 is 1, so I'm going to change signs around 3. I'm going to stay the same sign around 0. I'm going to change signs around negative 3, so I can get the answer quicker doing multiplicity. If you did it one by one, doing the test point, you should have gotten that same thing. Okay, cool. Is that cool?
Wait,
Is that,
which one do you plug that into? Each of your test points?
into this here.
Oh.
Yeah. You want to know the sign of the derivative, and that is the derivative function, yeah.
No matter what grid forms you have is what you use for the same function.
Is everybody cool with that? Is that what you guys got? Okay. And now, what's this first guy? Is it what kind? Classify this first guy here. So if I specifically say, what did I say up here? I said, oh, okay. If I say if I say something like discuss the stability at each point, what would the answer to this one be? Stable. I like it. So attractor and stable are just two different words for the same situation, but be careful about the question that's asked. Right? Normally I'm pretty cool with either way because they both mean the same damn thing. And of course this one's going to be repeller. So why don't you make a nice problem with all three of those suckers in there? So what's it going to look like up here? Let me put it over here. Get a little bit easier. What's it going to look like up here? It's got to be going down, and it's got to approach this asymptote here, right? So it's got to be like this. In here, it's got to be going up. So it's got to look like this. Yeah, and then down here, it's going to look the same way. I love it because it's going to repeat around 0. And then down here, it's going to look like start off close and go down from there. This has got to be going down, and it's got to be asymptotic here. Is that cool? Yes, sir.
Would it be wrong from 0 to negative 3 if you just like mirrored the image? Like, started from the left and going down.
So, I'm sorry, say it again. How would it?
From, you know how like you did the exact same graph from 0 to 3, from 0 to negative 3? If that was the same image that mirrored,
Oh, if it was this?
yeah.
All right, so what would be wrong with that if it was like this? What's wrong with that?
It will be decreasing.
Slope has got to be positive. Yeah, yeah. And of course, that's as we read. Yeah. Left to right. Yeah, like it? I like it, I like it. Is everybody decent with that? So asymptotic, just it could mean back this way it's got to approach, or up that way it's got to approach. It could be either one depending on what the slope has to be doing. Okay. So if I told you, if I gave you an initial condition, if I didn't say sketch these, and I just said, sketch what it looks like if y of 0 is 2. Yeah, they're extra parentheses. If I said y of 0 is 2, what would it look like? Well, where's 2? In here. So what I really want to see when I say y of 0 is 2 is you go, bam. And where you're at 3, there's an asymptote, right? And at 0, there's an asymptote. And you just make sure it goes through the point. You guys see what I'm saying? So they give you an initial condition. This gives you what the form of it is. You just make sure it actually goes through. Did I do the right thing? What did I do? I love it. Good job, Jeff. So here's your asymptote at 3. Here's your asymptote here. Y of 0 is 2, and it's got to look like this, Jeff. There you go. Cool. So the form, and you just make sure it goes through that point that I give you. So if I said y of -1 equals -8, it's going to look like this. You just draw that form, make sure it goes through that point. Do you guys get that? Okay, I like it. So the output of the initial condition tells you what form it's going to take. And then you just make sure it goes through that point. Put your asymptote on there. It's all good. I like it. Cool. I like it. Okay. So those, don't let those be bad. It's very much related to stuff you've done before. I like it. Okay. The section 2.2 we've basically already done. I'm going to do a couple examples real quick. This is the separable stuff that I told you about, just to kind of satiate the desire I knew you had to have something to freaking solve. So now we're finally, in 2.2 and 2.3, you're going to be like, what was I wishing for? But the rest of chapter 2 is where is the heart of Diffie-Q, which is what I try to do depends on the form of the equation. So you have to learn, one thing we have to learn is how do I classify the form it's in. And of course the other part is what the shit to do for each of those forms. Right? There are some DEs that are in multiple forms, so which way do you solve them depends on which way is the easiest to solve. The hardest one? Sure, just to challenge yourself. I like
Do we
it.
get extra credit on the test?
Hell no. Why do I get the extra credit to make it harder? No. Sorry. You don't finish it. You're like, I was going for the extra credit. So section 2.2 is all separable. So let me give you, let's do an example that really kind of fleshes out the little things you got to be careful about. Now this is a form that they could give you a DE in. I don't know if I've written it like this yet. Maybe I have. I think I did at the very beginning. So how do you tell this is separable? Well, I'm very easily able to get all my Y stuff together, all my X stuff together. Let's see how far you guys can make it. Try to do that. Get all your Y stuff on one side, all your X stuff on the other. Please, dear God, does everybody understand that if dy is on the bottom, you can't do shit with that? Okay, I always have somebody do that because it's easier. Like, I don't want to put the Y on the bottom. I want the Y on the top because then it's Y squared. No, it's not. Because your dy is on the bottom. Makes no sense. Please. Okay, try to do something with this. Maybe move my camera over here now. Oh, that's pretty close there. All right. It's not something I made up. I can't blame the guy for being optimistic. Sometimes that leads you to incorrect answers. You can't just flip this and make it easier to integrate. It's too bad. What are you guys getting for this here? ln of?
Absolute value.
Is this one I need help with?
Oh, and absolute value of 1 plus x.
Now see, separable will be your standard 180 kind of plus C situation to start with. Because separable is basically 180. Starts off non-180 and becomes 180 very quickly, right? This is almost our last connection with 180, so appreciate it while I can. Where do I go from here? I like it. What'd you say? Did you say E it?
Yeah.
I love it. That's exactly what I say. E it. E both sides.
Yeah. I don't want to move.
So then you get absolute value y equals absolute value 1 plus x. Yes, e to the c. Now, how can you take the absolute values out? If you take the absolute values out, what do you have to do to cover your ass for that?
Restrict, so it's greater than 0?
No.
Okay. That.
And then what's this?
C2.
Like C1 or something. If I call this one C1, then yeah, I can actually just call this C then. It's not a bad idea. Now that is a very different answer than you used to, really. Is it? Right? You don't normally, in 180 you certainly wouldn't get this. So that's what I meant by it starts off like an old 180 thing, but when you start to simplify it, that C gets sucked in somewhere that you're not used to seeing it. So this is a nice family solutions to this DE. I like it. Is that cool? So the only way that separable gets difficult is if the pieces parts become some really disgusting integral, which will happen every now and again. You have to use by parts or something. Yeah?
Oh, I'm sorry.
Oh, so what is e to the constant? It itself is a constant.
Eat anything.
Yeah, so and the plus or minus just gets sucked into it also. Because I have total control over C, so the plus or minus is not needed anymore. Is that cool? I like it. So yeah, if you want to, the first C you introduce, you can always call it C1. The minute you rewrite it, based on it's now a different constant, call it C2. And when you're done, you can just call it C. All right. Okay. Let's see. Let's try another one right out of the homework, and then we'll move on. I didn't pick another one out.
Is it times bases 1?
Yes. And is everybody cool with how we got from here to here?
That's what I'm at.
So what is e to the a plus b? Well, when do you add powers when you were multiple? So that's
Happened.
yeah. That sucker happens all the damn time. So we gotta get used to that. Okay, I like it. And you know, in this section, you will also see some initial value problems. So you'll just have to figure out what C is to make something happen, right? So they could have said, what if y of doesn't really matter, Jeff. 2 is supposed to be 6. Yes, sir.
Can we go over again why e to the c went to just c,
E to the C1.
or e to the c1?
What kind of thing is e to the C1? E to a constant is
Oh, it's just
a constant.
Okay.
I love it. And the plus or minus is still part of the constant. You can make it positive or negative.
Okay.
You have control of your C's. What's going
Please,
on?
dear God, don't let me just steamroll you right now, because if you don't quite get that, it's going to get a little more complicated later with the constants. So this is the first level of dealing with constants, because you do have to kind of transmogrify them on the way. You don't have to, but you see how that's so much prettier, and it captures the same information in a much nicer way.
The other one goes more.
Huh?
But the one step before goes
Yeah,
more.
C1 doesn't like it because he got, he's the understudy now. I'm sorry, you? Did you? What? Yes?
So, on the test, it would be wrong if you put the answer right at that point.
I mean, this wouldn't be wrong because it is sort of a choice to do this. This isn't wrong. It can't be. But do you see why it's convention to go this one more step? Because if I told somebody the solution is this, they go, well, what? That's just a constant. What are you talking about? But I'm not going to take points off for this. I'm going to put a note, for sure. A strongly worded note. And you're like, as long as I lose points, you can write whatever the hell you want to. So if I said this, the next step here would be easy, right? Is it? Yeah. So if I put a 2 in, 3 times c, so then c's got to be 2. So then the answer here would be y equals 2 plus 2x. Okay. So pretty cool with that. If I make x2, that's 3, times something is 6, that's 2. There you go. I mean, that step should be easy. Most of the time. Believe it or not, there are some situations where it's not. Yes?
Is that stuff difficult when there's a C2 or C3?
If there were more than one C, separate C, C1, C2, C3, then I would need
You need to solve
multiple
the first one.
conditions.
Finding them, so usually you go
So yeah, I would. In that respect, it's definitely more difficult.
I
Yeah.
guess we
Not difficult.
C, E to the C1 just to C. Does that get more complicated if there's more C's? Like,
There are situations where there is nothing wrong with this. There's nothing else going on. This is a constant. When we get to, like, for example, a situation where that happens is systems of differential equations. Just to give you a taste of where that's one of the last things we're going to talk about. And they're going to have C's that you have to kind of match up between the two answers. So then it's going to be very important to kind of keep track of what's what and why and where. Because then they're going to be matching between C2 and this one and C5 and this one. Sorry I did that to you. That's not for a while, okay? It's not going to be tomorrow. But just to give you an idea of why I desperately am trying to get you guys really kind of comfortable with playing around with C's, because later we're going to be playing around with a lot of frickin' C's. Okay. I want to do one more example just to... Let me see if they have anything freaky in here. Oh, yeah, well, sure. I mean, they have a whole little section where they tell you in the instructions, use a technique of integration or a substitution to find, they're telling you, okay, this could be u sub by parts, it could be trig sub. Yay. So I'm just going to let you hit those and come at me with questions. So last thing for today. So I think officially I'm going to make this just over section 2.1 and 2.2 because we're just going to barely get to 2.3 here. I always try to make my quizzes cover stuff at most what we got up to a week before. So you have the class in between ask questions on what we did. Isn't that crazy?
So this is all of 2-2, just separable.
Yeah, 2.2 is separable equations. And really, again, the idea is stupid simple. So how does a problem get hard? If they make these functions hard ones to integrate. They require, like I said, they might require trig sub. Or, and that's all they could do. So it's not the process, it's not the DE, it's just the function being hard to work with. So later we're going to get to where the DE gets hard to work with. Yeah. Hope everybody is cool with what you're in that. Sometimes I have somebody come up to me and say, "What? You keep saying DE, what is it?" Everybody with me on that, right? I'm like, it's you're in it. So this has come up before, but it leads to a process of how to solve the DE if it's linear. So what was the idea with being linear? I think I gave you both forms of it before. One form was this. This is linear. We're only talking about first order in chapter 2 for the most part. I can't remember if something else sneaks in. Higher order derivatives come later. So when I say linear for chapter 2, it's first order, meaning it's going to be involving at most a first derivative. What did they put over here? G of x? Yeah. And then if I divide by this, I have this other form I could put it in. Now, I think they put, in this section, they put f of x here. Later, we're going to put a q of x there. Again, it doesn't really matter. It's sort of like calling something x or y. Who gives a shit? So I'm going to mimic what they do in this section for this. So the process, with the time I got left, I just want to show you the idea behind what we do to solve this. Now, some of these will be separable. And dear God, if it's separable, I do that, right? Bless you. For the most part, there are a few where actually it's not easier to do that. And again, it depends on the functions that are there. But almost all the damn time. If it's separable, that's the way you go. So let me see if you guys, let's see, how do I want to put this? All right, let me just put this down here. What would this be? Okay, don't worry about, I'm using this specifically, but that's just the, you guys know what this is?
Mu.
Greek letter mu. What they call French cow. So this you see in statistics for the mean of a population. But for us, it's going to mean something else. So what is this fundamental? This is Math 180. This is just, what would I use to do this? All right, do it real quick. Just write out what it would look like, the result. So it's just product rule, nothing major there. So what do you guys? So you get d mu dx y, right? Plus mu dy dx, right? Kind of wrote that the reverse of what I wanted. Let me write it again. Mu dy dx plus d mu dx y. All right, that's what it is, right? That's no big deal. Jeff chose some weird ass letter there. Who gives a shit? It's a function. I can do it. Okay, no big deal. But now notice this. Notice how this relates to that form. If I multiplied both sides of this by mu, now go with me. This is not immediately obvious where this is headed, but you just have to go with me here. So do you see how that's there? So if this equaled that, then this whole side could be written like this. And let me see if you guys get this. Just to give you a little motivation as to why that's awesome, how would you integrate d sine x over the natural log of x to the e to the x power?
Called
No, come on.
multiplication.
Well, okay, look. What's the integral dx? What's the integral dx?
1 over x.
No, come on.
1
X.
over x.
You're like, something must be. Something must.
It's been a while.
So what's the integral of d? Who gives a shit? Who gives a shit? I'm undoing that derivative. I know you guys have seen this before, believe it or not. I'm trying to remember, where's a good example? That basically just goes away. The integral of 1 with respect to this is this. That is the variable for this integral. It's with respect to this. That's really why this is x, because of that. dy, y. D, big ass expression, plus c, right? So if I can write one side like this, I multiply the dx up, and this side, the integral, is this. Yay, right? So let's see. So in order for me to get to the point where that is true, what must be true about this expression? That is here, so that must equal that. So d mu dx times y must equal mu px times y. So d mu dx must be mu p of x. Now, you guys never learned history of math, and trust me, there's a lot of these processes that I'm sure at some point you're like, what the shit did somebody do to figure that out? Sometimes it's purely playing around with shit. You got to trust me. This specific one I can't remember, to be honest, but I mean, because that's what's missing from a lot of math education is the history part of it. But that's where you guys should go and fill it in yourselves. I haven't looked this one up in forever. I can't remember what the history of it was. So watch. What form of... Now, I really... This is going to happen a lot. This little equation came from where? The requirement for me to be able to write that side like this means that that piece... Where'd it go? That piece has to equal that piece, right?
You divide y out and y became 1.
So now, how do I solve this thing? That's not the problem, but that's a little piece of it that lets me do something that makes it easy. How do I solve this? What form is this in? Probably the section that we just got out of, the only thing we know how to do. Separable, right? So this would be d mu over mu equals p of x dx. You get natural log of mu equals integral px. So to cut to the chase, you get mu equals e to the integral p. Get out of there. Yeah, you're fine. Yes. So I know I took an interesting detour there, but let me really break it down. When I have a linear that's not separable itself, I have to attack it a different way then. I try to find what's called an integrating factor. A function I multiply everything by that makes one side condense. It makes it easy to integrate, and then I just have to worry about integrating whatever the shit happened on the other side, right? So when is this hard? When that shit's hard. This side can't be anything but easy. Because you end up with integral d this shit equals that shit. That side's always easy. And again, we're just talking about this. If you're like, what just happened? You gotta let it kind of sink in a bit, right? Do we have time for an example? Yes, I love it. Let's do a quick example. I can't remember if this is the way the book does it. I don't know what way the book does it. I'm not gonna worry about it. Okay, so let's pull a problem right out of the, not my ass, but the homework here. Let's see. Not where I normally pull it out of. Blah, blah, blah. Let's do one that's not, yeah, let's do that one. Well, it's not separable. Let's see, y prime plus 2xy. You guys agree with me that's not separable?
Yeah.
Yes.
Okay. Is it linear?
Yes.
Yes, because it's in this form already, right? They might start off here, but you got to make it look like this so you can identify P. You with me? If there's a coefficient of y prime or dy dx, you must divide by it so you can see what p really is. I like it. Strange phrase to hear out of nowhere, but how do I figure out what mu is? Well, now we know the general, always true thing for a linear dE is mu is going to be e to the interval p of x dx. So what is p? Oh shit. 2x. P of x is the coefficient of the y term. So be real. Don't do that to yourself. So see how it's just a function of x. So mu, the thing I got to multiply both sides by, is e to the integral 2x. So this is going to become a mu. E to the x squared. Now don't worry about plus c, okay? That's a part of this, is the plus c doesn't really matter, because it would just become a multiplying constant like this, and it would just kind of get absorbed in the whole thing. Don't worry about the plus c on this level. This is just the little intermediate, what's the function I got to multiply everything by. Okay, I like it. So if I multiply, now watch. I'm going to show you what this looks like. E to the x squared, y prime, plus e to the x squared, 2xy, equals x cubed e to the x squared. Now, most of you, if you're not really looking at the correct side, you're going to be like, thanks, Jeff, that's fantastic. It looks so much better. But again, this side, I don't care how ugly it looks. What will it always become? It will always become all right, I'm going to make you figure it out directly. What is this the derivative of? Let me do this. Do you see how that's... All right, now watch. Isn't this a product rule? That's really what it fundamentally is based off of. So this is when y was taking a derivative, and that was left alone. And sure enough, now check it. This guy's derivative is there. Y is left alone. Hey! So it's always going to be mu y. That's what I had up here earlier. It's always going to be, that side is always going to be d mu of x times y. What's up? Want me to do that again?
Just like the last 20 minutes need to be redone.
Oh,
I'm
thank
just
God
confused.
it's still going, right?
Yes.
Yes? Okay. It's all down there.
Just let them know in craft class.
Hopefully that, I tried to frame this in a way to connect something that seemed unconnected at first. I know it did, and it just has to. It's just playing around with shit, and then you go, hey, that looks a lot like this. It's exactly equal if there are certain things met. How do I make those things met? Oh, this thing. Oh, so that's the thing I multiply by to make it become nice. That was the whole first part of this, was just some derivation. That leads to this being the rule. If the linear dE is not separable, I attack it with an integrating factor.
So use like an actual thing.
That you need to know that you
Like,
That
it wasn't
is the
just
key.
something that you were like making up. It was like an actual thing in the class.
Yeah.
Okay.
I try not to waste your time with just
that
complete
U
shit I
equals
make
that
up.
E function is important.
That was important. I know, listen,
Yeah, so it's just like
the higher up in math you get, the more disconnected things kind of seem at first. And it really is because, not everything was, but some of the stuff we figured out is just by playing around with shit. It totally was. You gotta believe me. We don't teach math the way it was discovered. We teach math the way that it makes sense now. Because math was not discovered Calc 1, Calc 2, Calc 3. And why do I start with calculus? Because that's where math starts, by the way. That's not the way it was discovered. That's the way we teach it, because it's the way that it kind of makes the most sense. The first thing that people really work with that led to other things were infinite series, to be honest, which is really weird to understand, because that's the part you guys hate the most. But
No, no, really.
not everybody.
Adding and subtracting, that's all the
It's
series
just
is.
takes so much ass. I'm sorry. So let's finish this problem out. So again, this is always mu y, which is awesome. But you can always also just figure it out. This has got to be y, and this has got to be e to the x squared, because there it is, and there's its derivative. And this is mu, and that's y. Okay. Equals And what's really nice on this side? Well, it's not quite so nice, but what are you going to have to do on this side? What would be better is if this was x, right? Or if this was x to the fourth. But it ain't. Too damn bad. So what are you going to do instead? So because the next step here is to integrate. Here, I'll do half. I'll do this half. Phew.
Thanks.
It's so hard.
Man. Are you guys done with that side yet?
You use G-sub or like,
Now, why won't you sub? You could try to, because you could certainly manipulate it.
It's power to a power is y.
It's because this is kind of like backwards, right?
Yeah.
Yeah. So if you try to let u equal x
first.
squared, then you'd have to, and then how do you get x cubed? Now watch. Du would be 2x dx. And if u is x, so let's see if this leads anywhere. And again, this is part of the playing around with math that people don't understand is a part of math. I'm not saying this is the right way to do this. Let's see. So this is x times x squared, e to the x squared, dx. So using my substitution stuff here, u is x squared. So this is u, e to the u, 2x dx. So I need a 2 there. Are you guys following?
yeah.
2x dx is du. Now that is definitely better. I have to do what here?
Integration.
By parts. But that is a lot better than what it was. You could attack this directly with by parts. And I think it comes out about the same amount of work, but this is actually a little bit cleaner. Now when you do by parts here, you already got u's in here, so you're going to have to do like m and v is what I normally do instead of u and v. You guys semi with me here? This is now 180. So, I mean, it's basically done. You just have to finish this out. I'm like out of time, but yes?
On the right-hand side where you have still the purple, doesn't that need like a dx over there? Like where does
Oh, yeah, I'm sorry. That's my bad. The y prime is dy over dx. Now it's d this over dx. So I need to multiply the dx up. That's my fault.
Okay.
I left it out because I was going to make a big point of it, and then I forgot it. But yeah, this is always going to be d this over dx. Multiply the dx up, and that's what lets you keep going. Thank you. Okay, that's enough. Hopefully everybody understands it's not done, but this rest of this is a 180 problem. It's sort of like when you were in 180 and the teacher said the rest is algebra, and you're like, can you do that anyway?
Yeah.
Now I'm going to be, the rest is 180. Haha. Only when I run out of time, yes. Okay.
How is that hard?
Normally.